This video is going to look at Group 7 tests for halide ions. So it's important that it's Cl-, Br-, I-, etc. Test for halide ions. As it says there, this forms part of one of the required practicals, so you need to know how to do the test and the observations. You probably have seen this either on a video or a demonstration class, or you've done it as a practical already. So I'm just going to go through some of the observations and the equations. So we're going to be using solutions of the halide ions. So those three there are particular halide ions within their salts. So to test for a halide ion, make sure you have a solution of the halide itself. You're going to add a small amount of nitric acid, and that's to remove other things that may interfere with the test and give you a precipitate when it's not really that particular halide ion, such as carbonates and things that will interfere with the test. All the nitric acid is doing is removing the carbonate, because it's acid plus carbonate, gives you salt plus water plus carbon dioxide type of reaction. It just removes the carbonate ions. You then need to add silver nitrate solution, and that's your main test solution. And remember to observe what colour the precipitate is that forms. So as I say, you'll probably have either done this or been demonstrated this particular thing. You do the test with a chloride ion, then you see a white precipitate, and it is important to know the colour and write the word precipitate in your answers. The actual precipitate itself, because you've used silver nitrate, is silver chloride. With a bromide ion, you would see a cream precipitate of silver bromide. With the iodide, you see a yellow precipitate of silver iodide. So do remember the colours, white, cream and yellow for chloride, bromide and iodides, and include the word precipitate. It's important to note that you can't use this test for the fluoride ion, because the silver fluoride that you would make, AgF, is soluble, so you won't see a precipitate, so you won't be able to see anything. So the reactions that took place, the precipitates that formed, you can write overall equations and ionic equations. You might want to stop the video and have a go at those now. For the first one there then, you're taking two solutions, your silver nitrate and your sodium chloride, and you make a precipitate of the silver chloride, so put a little S state symbol there, and you will also have sodium nitrate, which is soluble, so it's aqueous. Getting rid of your spectator ions, you'll see that you can write the ionic equation right down. The other two are shown there, so the reaction with bromide ion to give you silver bromide, green precipitate, a reaction with the iodide ion to give you silver iodide, which is the yellow precipitate. So the general ionic equation is Ag plus, which is aqueous, plus your X minus, whichever halide ion it is, aqueous, so two solutions, and then react to make your precipitate of AgX, which will be a solid. The silver halides that you've made, so your silver iodide, silver bromide, etc., have different solubilities in ammonia, so you can use that to identify correctly which one you might have. So you firstly add diluted ammonia, see if it dissolves. If it doesn't, you can then add concentrated ammonia, again to see if that dissolves, and the observations that you see will help you define which bromide you have, or which halide that you have. If your silver halide is fully soluble in dilute ammonia, then it must have been a silver chloride. If the silver halide precipitate is insoluble in dilute ammonia, but in concentrated ammonia it does dissolve and go colourless, then you must have had a bromide. And if the precipitate that you see is insoluble in both dilute ammonia and still insoluble, so it remains the same in your concentrated ammonia, then it must have been a silver iodide precipitate. It says you can use this addition of dilute and then concentrated ammonia to distinguish which halide you would have had. As I say, you may have done that in a practical, it's part of the assessed practical, so you should have done, and obviously there's videos as well to watch on the actual observations and the colours.